My name is Max Hayek, and I work for an Austrian game development company called Cliffhanger Productions. And I will hold a speech about, first, the interaction of game designers and programmers poses a problem. And that is, game designers usually have lots of ideas which they can't really test until they are implemented. And then they find out, well, this concept or this game mechanic or this value or whatever is not quite what I imagined, and they change it, and they change it, and they change it. Now, obviously, programmers, we software developers, are not too fond if change requests are coming with a frequency of multiple times per day. If we develop mechanics, implement them, and they are completely thrown out again. But on the other hand, from a designer's point of view, he doesn't really have a chance. He can't play with the system until it's not there, and until he can play with it, how should he know whether it works or not? So my speech is going to be about a framework that we built, which helps with that process, or helps us with that process. Maybe a little bit of background about the company, Cliffhanger Productions. We are specialized, or our target audience are games for more adult gamers, like in their 30s, who want to play and who already in their childhood or in their teenagehood played games, so it's not a completely new concept to them, not at all. They want complex mechanics. They don't want totally simple things like, I don't know, Farmville. On the other hand, they don't want to spend a lot of time because they have already children, many of them, and a wife that goes with children usually, and they work and so on. So it's not like they can put in a weekend and say, okay, now for the weekend I play all night through, like they did in their younger years. At the same time, to catch these people, to catch their interest, it makes sense to use familiar complex concepts, so that is role-playing games and strategy games, because they were in one complexity. On the other hand, it should be easy to access for them, to access those games for them. And it should be possible to slice your gameplay into short sessions, because, as I said, they don't have that much time. So they want to play it, I don't know, half an hour or an hour in front at the couch at home, on the tablet. Then maybe when they commute to work, they want to do this on the phone. They want to continue their game where they picked off, left off, and then maybe at work they don't go for lunch break but play a little bit too. So it needs to run in the browser too. This is basically our target audience. We have basically finished one game, as much as you can ever finish an online game, which is Jagged Alliance Online. It is a turn-based tactical game, so that was the tactical branch of our game target. And it's been released in German, it's been released on Steam, and right now it has already been released on Steam. That's not quite current in that slide. It's been released on Congregate. It is slated to be released in Japan. It is already released in Russia, and as such also in Belarus, I think. It's slated to be released, but that's yet taking time. The next one we are working on is Shadowrun Online. I don't know how many people of you know the brand. I personally didn't know it before we started working on that. Shadowrun is a pen and paper role-playing universe, which is playing in a cyberpunk sort of world. In this cyberpunk sort of world, you have the typical elements of cyberpunk, but additionally you have dragons and orcs and whatnot. Through some storytelling device, they made that possible. And so we are creating a game, a multiplayer game in that world, and it is a typical role-playing game. With a role-playing game, you get these mechanical problems for the designers quite a bit, because you have a lot of mechanics in a role-playing game. You have attributes, you have items, you have skills, you have active skills and passive skills. Active, you need to actually do them, use them, and in the right moment. and passive skills, they somehow affect your other actions. You have status effects. You have things that are temporarily attached to your character or to another character, which have a positive or a negative influence on your character or on your action. And so much more. You have player-to-player trade. You have competition. You have all kinds of complicated goals in a level. For example, you might have to trigger. You open a door and then kill two guards and then open a complicatedly locked chest and whatnot. So it's a complex set of winning conditions for quests. So role-playing games pretty much encompass the most voluminous set of game mechanics. And as such, this was the starting point for us to realize that problem that we see here in this little cartoon. There we have, on the right hand, we have this designer who is talking to the programmer and talking and all those ideas and concepts, and the programmer just looks, okay, thank you. Then he implements them, and the game designer comes with the next bunch of concepts, and please that, and please that, and please that, and at some point the programmer says, wait a second, let's do that a bit more efficiently. Let's find a technical solution for this problem, which he does. And in the end, you see that little heart. The game designer is all in love, not with the programmer, but with the solution. So now I'm going to talk about the solution that we discovered for our own, and it works quite well. The basic principle is to make everything as data-driven as possible. Now, normally data-driven means that you have some classes, which are in some way parameterizable, and you read those parameters from a database, a configuration file, whatever. But that only goes so far. Usually that means things like, if you have a formula, say you attack someone, the weights of certain values that influence the damage you do may be read from configuration. But that doesn't really help with the problem of solving or of reducing the frequency of changes to the formula itself. It just changes the parameters. It doesn't help with the problem that, for example, designers initially might think, well, a character has the attributes strength and dexterity, quite classical, and that's enough. And then maybe 3 months later into development, they find out, yeah, but for our purposes, it would be really important that characters have wisdom too. Normally, when you implement something like that, then you will have a class that somehow depicts the abilities of a player. Maybe it's the character class itself, maybe it's a sub-component. Anyway, somewhere in code you will have a property called dexterity and another property called strength, and you have it well tested and it's well integrated and all is nice, and now comes the designer and says wisdom. And now you have to go in most likely several places in your code, however well you designed it, and add wisdom. It's kind of a pain. So what we did, like the first step, is attributes such as this are not, there is no mention of wisdom or strength or dexterity in code. This is all data-driven. We differentiate between basically 2 types of attributes. The ones which have a more or less constant value, which may be raised through level up or something like that. So in a typical game, strength would be such an attribute. You spend 5 learning points or 2,000 experience points or whatever, so you have this at 5. And then at some point you maybe raise it at 6, but that's all there is to it. And then there are other attributes which usually are calculated from those attributes. So for example, you might have an attribute that describes your defense against fire. And into that attribute, and that attribute would depend on strength, because strength generally influences your resistance, your resilience, let's say. And maybe it is also influenced by your dexterity because you can quickly jump away, I don't know, something like that, whatever the designer comes up with. So the second kind of attributes, we call derived attributes because they really are just more or less a weighted sum of other attributes. And then attributes can be modified temporarily and long-term. Long-term, that's just what happens when you level up, usually in a game. You get some differs from game to game, but you get some way to increase your statistics, your attributes, and you do that, and that's the long-term change. But then there is plenty of short-term change. For example, someone might cast a spell on you, making you temporarily weak. So your strength attribute is going to go down for a little while. Or you yourself might drink a potion that just for the next 15 seconds increases your dexterity, so you're in order, you can, pick the lock of a chest which you otherwise couldn't. Or maybe someone shoots you, and because of the damage done to your leg, you can run as fast, and maybe there is an attribute speed. So there are modifiers and temporary modifiers which are attached and detached more or less this attaching and detaching can be triggered by all kinds of activities in the game. Now modifiers we can yet more distinguish between modifiers, two types actually. One is like someone shoots you or casts a spell on you. That is really relatively short term because usually that spell is going to run out in 2 or 3 turns or 2 or 3 minutes or whatever the game timing mechanism is. And the other type is you have, for example, some equipment. Like you carry the ring of wisdom and that makes you smarter. So that's relatively long term, although not permanent. In order to facilitate the later kind, because those more long term modifiers usually are associated with inventory or something like that, we have a concept of modifier providers, which is basically just you can attach that to another component, another logical component of your game framework and say, hey, this is a modifier provider and it gives these modifiers. Another concept are statuses. For example, in every game you have health. Health is not an attribute because it has a maximum value at some point. That maximum value may change, but it has this value. That's like the full value. And then it decreases through, hurtful actions. Or in games that feature magic in some way, you also have mana, usually, which is consumed for casting spells and some such, and replenishes over time or by drinking potions or whatnot. So when we say status values, we think of entities or of values which have a very fluent nature and which usually, but not necessarily, decrease over time. Then there is flags. A person might be temporarily crippled because you fired a crippling bow shot at him. So the mere fact that he is crippled by itself doesn't mean anything yet, but it is an information to be attached to the character, and that is what we call flags. And then there are status effects, which is the whole concept of being crippled, with all the consequences. So being crippled in game A might mean you walk more slowly. In game B, it might mean you are completely trapped. In game C, it might mean that you have a lower chance to hit. Now let's look at some code. Now a laser pointer would be fine anyway. This is obviously, those are tests. Obviously in production code, we take this from data. But for the purpose of demonstrating and also of testing, this is quite useful. What you can see here is, basically we define a few attributes, and we have a few fixed attributes, those value-based attributes, strength, agility, wisdom. And then we say there are derived attributes and they have a certain relationship, at dependency. You see the at dependency calls in the middle. They have a certain relationship basically a weighted sum to the value-based attributes. And then you can set the value-based attributes and kind of automatically the other attributes will adapt. Now that doesn't look like much, but it is a first step. So as you can see, in the game there is no mention that we do have here constants like ID strength and ID agility and whatnot is really just because it's a test. In production code, we don't need those constants. All that comes from data. So in the game logic of any game that we do with this framework, we don't need to fix or refer to such attributes, which means, and this is why this is important, that a designer can, at any point in the development cycle, relatively easily add a new attribute and insert it into their game logic. I say relatively easily because it is no effort for a programmer. So from a programmer's point of view, extremely easily. For the designer, obviously, he still will have to think, okay, what do I do with this attribute and where should I, and what connections to other things, other game rules and entities and mechanics should it have? But that's a different story. That's their work anyway. We kind of eliminated the work part for the programmer here. Now you can see this is just like you set the value-based attributes and the derived attributes will automatically adapt. Now this is about the modifiers. Here we have a modifier which is an additive modifier, which just adds 7, and then it says also, okay, I belong to the ID mana attribute, and I will modify that. Again, a designer can use an editor to create these at any time. And we can even be in alpha, and the game can be played already by people, and designer just adds an attribute or adds a modifier, and it works. We don't even have to redeploy code. We just have to redeploy data. Then the modifier provider thing that I mentioned, typically an inventory or equipment belts. In some games you feature like rings and belts and whatnot. So you have to have an item equipped and then it has a certain effect. Typically this would be modeled by a modifier provider. Here this character inventory thingy, I didn't copy the code here because it would be like too much for a slide and maybe too detailed. But the character inventory actually is a modifier provider and as such has this call and wraps the call for give lesser trinket is really just you wouldn't use that in production code, it's just here for demonstration purposes. You wouldn't actually refer to the name of an entity because the whole purpose of the framework is for technology to be agnostic of the actual entities. Yeah. Now, this was like the first step, the attributes, but it's not, I mean, it's nice, but there's still a lot of other things that designers could think of and change requests that they could make that we don't cover with that. We don't protect ourselves against those change requests. At the heart, now I need to take a step back and look a bit at the heart of the whole framework. The heart of the whole framework is that we say our entities in a game are composite entities. That means, conceptually, they consist of several practically disjunct components. Those components do not necessarily talk to each other. We don't necessarily want those components to have hard references, even through interfaces to each other. Because if you have 20 or 30 of such components, you find that even with interfaces and the usual mechanisms of indirection, it gets somewhat cumbersome. And also, mostly, these components are rather self-sufficient. For example, if you have an inventory, it doesn't really care much about the attributes of the character. If you have the attributes of the character, they don't care about the inventory. If you have an animation component, it doesn't so much care about the inventory, but just a little bit. So most of these components are rather disjunct, but still they belong together. So what this composite thingy does here, that's the interface definition here, is it basically allows you to add any type to this composite and then later tell the composite, oh, please do something with all your components of type X. For example, you can ask the composite, oh, well, if you have a component of type inventory, then give me the number of items in there. And you don't necessarily have to know whether there is actually an inventory in this composite. You don't. It's no hard reference. Actually, if at some point you change that, you remove the inventory component from the composite, the code will still run, which is good because it allows you to generalize. So, for example, our NPCs, typically non-playing characters, agents used by the computer as opponents, they usually don't have an inventory because it's pointless, it's not needed. At the same time, in many, many ways, we want our code to interact with NPCs just like with player characters. And by the mere fact that as a caller of this, as a user of this composite, you don't really have to know which components are there. You just say, if something is there, do something with it. Or for all types of these components, do something with it. The code stays stable against the exact composition of the exact instance that it right now works on. So you, to the same code, you can pass an NPC, which has an inventory, and a player character, which no, it doesn't. And you don't have to change the code that manipulates that. So, for example, a character, I mean, that is, of course, again, a test example. A character might consist of attributes, status values, which we already discussed, an inventory, and status flags. And then what we see here in the constructor, actually even the fact that it has a property like attributes, status values, inventory, and flags, we don't need that in production code. We need it for the test and here for explaining because it would be kind of boring and mostly it's not so interesting to look at data files. So instead of data files, we do it here with constants. But really, in our production code, there is nothing like this. In our production code, the character inherits from composite and that's pretty much it. There is no explicit mention of either of those components and there is no explicit setting up of those components. They are read from a configuration file. So that means a designer can say, hey, I want a dog entity. I want to introduce a new entity into my game. Say it's a dog. And say the dog is a pet. That means it is friendly to the player and it helps the player independently or maybe following orders. And now for the dog, I want, because it's a dog, I want to, it can have some sort of color, a color component, like dogs have. And maybe the color is an equipment slot, really, that can be used to put something there which makes the dog stronger. But it doesn't have any other inventory, but it does have some statistics, it does have some attributes, not all of them, not the same ones that a player character would have. And whatever else components they think of. And they have their editor, and just add a few of those components. Save the whole thing through an export pipeline, and in our game loader, we just load them. Basically, about that, it's JSON files that we load in the runtime of the game. So at production time, we don't explicitly know that a character consists of this and this component, and the dog consists of another. We don't even know really that there are dogs as such. We don't even know really that there are characters. Well, characters are a bit of an exception because they are so special and they have other meanings too. But most of the entities we don't explicitly know about in code and we don't know about their structure. That is all defined through data by the designer, which again shields us against the ever changing mind of designers, game designers. Now, the next concept, and that is a very central concept for us because it covers most actions that the player can perform in a game, are activities. Basically, an activity describes everything that one entity in the game can do to itself or to another. Activities rely on three to four, depending on how you look at it, 3 to 4 other concepts. One of them is conditions, basically predicates, that check for something and say it is given or not, a Boolean. Effects, which are basically changing state in one of the components of a character. Costs, now the costs, that is an interesting question, whether we want to regard it as an extra concept, because the cost in our framework is really just a combination of an effect and a condition. I'll come to that later in more detail. And then we have calculations, because designers, for example, when they want to calculate the damage that you get from a bow shot or from the fire spell or whatever, they want to play around with the formula, and they maybe don't want to just change parameters, but the actual formula. And for that, we have calculations, functions, as we call it, which are also data-driven. So here, in this example, we see that first, again, here in constants, in production code, it happens directly from data. First, we define a cost for a status value. We say, if this cost is applied, then deduct something from the doer's mana. Then, if this is applied, if this activity is going to be run, then we want that the doer, the one who's active, the subject of the activity, also has to have a certain item in somewhere in possession, a scroll, and that scroll will be taken away. And we combine those two into a combined cost. That's the first 3 lines of the function. And then we do basically the same for the effect. We say, okay, the one who's hit by this activity, the one who's the victim or the target, will lose some health, so we give him damage. That's the deal damage effect there. And it will be, at least for some time, there will be a modifier attached to this entity, which decreases their strength, which we have in the create additive modifier, strength attribute, blah. And again, we combine those 2 effects into a combined effect. As you can see, because all those are constants and the numbers are constants too, or IDs, this all can come from data. And then we say, okay, let's create an activity with this cost and this effect. And what does that mean? When the activity is run, it will check, an activity is always run on 2 entities, a doer or a subject, and a victim or a target. For certain activities, the doer and the victim, or the subject and the object, can be the same. For example, if you heal yourself, then you are both the doer and the target, but that's just a special case. First, the activity checks, does the doer have the necessary cost? Is he able to afford the cost? And cost is arbitrary, as you can see here. The cost can mean, in this case, he has to have an item and he has to have enough mana to afford a deduction of 3 mana units. If the cost is given, then the activity runs through. If no, it doesn't. And once it runs through, and there are several other checks, we will come to that later. I'll come to that later. Once it runs through, it executes the effect on the victim. And in our case, the effect on the victim means, okay, he takes some damage, and his strength attribute is diminished for a certain time, or until he is debuffed, until he himself heals, or another character maybe heals him, or whatever the specific game world wants. And as you can see, actually the whole activity, because the activity, all the properties of the activity, are conditions and effects. And you can see here in clear detail that conditions and effects only depend on constants. And such, activity itself only depends on data. So the whole activity class classes, all those instances are again loaded from data files, which means at any time in production, relatively late too, when normally it is quite stressful, like when you are close to release, and then the designers think all of a sudden, the mid-game is not hard enough, and we will lose people because in the mid-game it gets too boring. We have to add new somethings, new skills usually, new mechanics. That's quite a typical pattern. And then they tell you this 3 weeks before release, and there is a load of bugs in your Jira or whatever your bug tracker you use, and your producer says, well, that's really bad, but if they say we need it, otherwise the game won't monetize, you have to do it, boys. And I mean, I don't know how many, I suppose most of the audience are programmers. You can imagine that is not a very comfortable situation. Now, our programmers don't have a lot to do with that. Our designers just create in their editor a new activity and reference existing effects or invent new ones, and they can change the game quite dramatically. Of course, they cannot do completely new things, because, for example, with each effect, if you cast a spell on someone, and then you want the visualization too, and for certain types of visualizations, we might need code. Many we can abstract away so much that we have written code for, say, 10, 15 types of visualization, and that might cover a lot and be parameterized. But of course, a designer could have the idea, well, it should be yet a little more different, and then we will still have to write a little bit of code. But in comparison, the game designer has a really powerful tool to change the game without requiring us to write new code, which leads to a different cost-benefit analysis. At that point, 4 weeks before release, when it's really stressful and there are all those bugs and everybody is really crunching, the producer will agree with the game designers, yes, we need to change, absolutely. But he won't agree with the game designers, we have to introduce something completely new which requires coding, if there is already such a huge toolbox that you can use, which doesn't require. So the decision is shifted to something more reasonable, something that gives the designers what they need, and as such makes the game a better one, without adding more strain and enormous stress on the programmers. The activity has more than just those cost and effect properties. It is actually quite powerful. It checks certain. It can have certain checks on the attacker and the defender. The difference to cost is that cost is always deducted. So, for example, it might cost you a certain amount of mana to try a spell on that girl character next to you to undress her. But you might not succeed. Still, the mana is gone. On the other hand, in order to perform that spell, you need to know it. And that is an absolute condition. You can't even try before you found the spell book for it. So there are two different kinds of conditions. One are those which are associated with cost, and even if you try and you fail, the cost is deducted. And the others are just absolute checks. You have to do checks on the target. For example, if you want to try the undress spell on a dog, it's kind of pointless. So there is a check, supposedly, that says, hey, no, undress works only on humans. Then you can also, a spell can also have an effect both, or a spell, an activity, whatever. I just say spell often, but really it is independent of these concepts. An activity can often have not only an effect on the target, but on yourself too, a more complicated effect. For example, you could have a necromancer or something like that, who is able to, damage an enemy, but at the same time has to damage himself. Most of these two effects on self we can cover with cost, but sometimes if they are complicated, it makes sense to have an extra effect for them, which is an extension point really in the system. Then, when you look at the different run-for methods, you see that all of them have this attacker and defender. Some of them have an environment, and environment is really just a collection of basically key value pairs for parameters, for numbers. It's basically just numbers and booleans that are taken from other components of the system. Partly they are just really calculations, and partly they are complex things. For example, if you have if the game considers cover when you shoot at someone, and the game makes a difference in your chance to hit, whether the person stands, I don't know, behind a table or a barrel or not, if that is something in your game you want to take into consideration for the chance to hit. Calculation, then, that obviously is so complex and goes outside the whole game logic mechanic topic, because it has to interact with the word representation and with physics in order to actually find out that there is something like cover between the shooter and the person being shot on. So other systems in the game can fill the environment with data that is too different. If those systems are too disjunct to be easily generalized and fit into this abstraction that this framework creates, and there are such systems, for example, animation and physics are good candidates, then they can fill their relevant data into this environment, which is also taken into consideration by the activity, but really not in code. Again, the values from the environment are really just forwarded to functions, which is another concept, and the functions, the actual calculations and checks being done in functions, come again from data, are defined by a designer. The other distinction that you probably notice here is we have run for and dry run for. Dry run for is really just a convenience method. Typically when in a game someone hovers with their mouse over a button, then they want to know what's going to happen when they click this button, and there's a tooltip and that says, okay, this will execute spell Great Fireball. Great Fireball has a radius of 8 and will damage any living creature in the area, but not undead creatures, and blah, 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 blah. Sometimes you want to also tell the user, okay, if you click this button, it is going to do so much damage. Exactly so much damage, depending on the game. Certain games don't give exact information out, simply because they address a different audience, and other games are very exact. If your audience are like hardcore players who invest a lot of time into the games, then you can assume that they will want to know every calculation in the game to the last comma, and they want to know every value, etc., so they are happy and they can optimize. If you, again, on the other hand, have a more casual audience who say, hey, come on, I want to play this game, I don't really care whether it's 5 or 7, I just want the stronger one, and you don't want to expose those values. For this first case, for the hardcore players, somehow, because all our calculations are data-driven, we cannot tell the results before we actually execute them. So this is why we have the dry run methods for it. They really just act as if they executed the activity and can produce any kind of output, which is put into the return value activity feedback, which can then be used in the user interface of the game to give information like, for example, if you now shoot at this guy, he will take 3 regular damage, 2 damage to his armor, and 7 spiritual damage, if you have such a game. And I think, yes, I think this covers activity pretty well. Then, as I mentioned, we have these conditions. What kind of conditions have we covered in our system? We have the logical combinations, obviously, for the designers. We have attribute-related conditions. You saw some such already. For example, someone has to have wisdom at least level 10 to use the magical sword. Or they have to have strength at 15 to use an extra bag in their inventory. Then we have flag-related conditions. For example, you can't cure someone unless they have the flag being sick. We have status-related conditions. For example, if your health drops smaller than 10% of the current maximum value, then you get into a special state which is called rage, and you do double damage. Money or wallet-related conditions, obviously. So in order to buy this item, you have to have enough money or whatever. And parameter environment related. Environment, again, what I mentioned before, environment is really, and parameters is really about joining the system with external components. Costs, as mentioned, consist really of a condition and an effect, and usually the two are very symmetric. That means, for example, a typical cost could be, hey, in order to buy the sword, you need to have 5 iron. So the cost object in the framework would consist of a condition, has 5 iron, and of an effect, take away 5 iron. But not necessarily. Sometimes maybe a designer wants to make this asymmetrical. So far it hasn't happened. We have, for most entities that exist in our game, we have fitting, in our framework we have fitting costs defined. And then we have effects, and as you can probably see, the effects are rather a very, very central component, because that is what changes state. Effect is the only component in the system that can change any state. Costs can change state just via their effect. Activities can change state just via the effect too. That also makes things a bit easier to test and to develop, because we know that everything else is behavior-wise immutable. So that helps with certain threading issues and whatnot. You know only when an effect is executing or executed, then actually state changes. And again, we have a whole list of types of effects that are already implemented, and as with all these things, there are interfaces and helper classes and whatnot. So the game programmers, we have split in our company like the tools and technology team, of which actually a huge part is sitting here in Minsk. 3/4 of the team are sitting here. And then we have game project teams. And the game project teams can, of course, implement an I-effect interface or an N-effect interface, abstract class that has some helpers to create something specific. That is good, because I'm coming to the end. As one can see, if for some reason in the prototyping phase of the game you don't want to work with a load of data yet, because the designers don't maybe in the prototyping phase often there is no designer yet, or not full-time there. So you want to make things a little easier, and you don't want to have to deal with all the data loading and whatnot. Then you can do it like that, and you can just hard code a few constants in your code, and it will be relatively easy to exchange that. Here it says health status, to exchange that later for reading that value from somewhere else. Another big part of the framework are items, and this is actually the last slide. It's very long. Anyway, items and inventory and equipment, we kind of abstracted the whole thing into 3 parts: blueprints, items, and bags. A blueprint is really just a description of an item. An item is the actual instance. So you might have the blueprint for the Super Dragunov gun, or the heavy metal sword, or whatever, and then there are 20 instances lying around in the game. And the bag is a container of items. And now if you think in a game, in a role-playing game, you usually have an inventory, that's your bag, you put stuff in there, then you have something, a head slot, and an arm slot, and a trouser slot, maybe rings or belts. And for example, in Shadowrun Online, you also have augmentations or bioware, something put into your head to make you smarter or whatever. And if you think about that, even all of those really are bags. Just some of those bags have only one slot, like the head slot. You can't put two heads on your head. But it's really just a bag, abstractly, with one slot. And others, like your rucksack, have more slots. And here in this slide, you can see basically how we build up the whole. First, we say, hey, the guy has an inventory and it consists of 10 slots. And what you can put in the inventory, the total amount, is limited by a size. Size is an abstract, but of 100. Then we define the equipment. The equipment consists of right and left arm, of head, and torso. And we say, okay, this is, he can put on a jacket, he can put on trousers, he can put on gloves, and maybe a crown. Then we define bioware or augmentations, which would be something in a science fiction world. And then we see all that together, the inventory, the equipment, and the bioware, we call that storage. And then, which is interesting, we can route any item into the right or the most right place in that storage without knowing about the actual structure. So that means if you gain a new item and say you gain new ammunition, and this ammunition fits into the gun that you have currently in your right hand. And the gun in your right hand has an ammunition slot, which is just a bag too. And that ammunition slot is not full. Then automatically by adding an ammunition item to storage, it will find its way into that gun, into the ammunition clip, will fill up the ammunition clip, and only the rest of it will go into the inventory, into the rucksack. So which means the whole logic of finding the right place somewhere in that whole character to put stuff and also where to take it from is covered. And with that, because I think I'm at the end, I could talk for ends, I'm a long talker, but that's a bad habit of mine. With that, I'm open for questions, and there you go.
Thank you for your presentation. I have several questions. Wait.
Раз.
Yeah, thank you twice. So, could you please tell us what classes do you have for an attribute, for example? Exactly what classes do you have in your final product? You showed us some maybe system classes like activity and something else, but do you have any classes specifically for an attribute of a character?
We don't. That's the whole point of the framework. We don't need any specific classes for a specific attribute because this framework enables the designer to define all attributes through data. So there is no need in the actual game code, this is framework code, to define a string attribute. It's not necessary.
Yeah, okay, but no class for strings attribute, but do you have attribute class at all?
No. I mean, other than using those two that I showed you.
And no specific classes for skill, spell, for example?
No specific classes. We do have specific classes for the animation or the what you call it, particle systems or whatnot that might be used for visualization of a spell, but not for the logical part.
Mm-hmm. Okay, thank you. And you showed us some examples of assertions in the code, but you didn't comment on it.
Well, that's just because I took the code to show you from our integration tests.
Yeah.
We have integration tests, and in the integration tests there are assertions. But I didn't think that this was particularly interesting because all of you probably do unit testing and integration testing, so I wasn't commenting much on that. But if you have a specific question, go.
Yeah. Do designers write these tests or
no.
programmers?
Those are tests for the framework. And the designers conceptualize about the framework, conceptualized, because the framework is finished, conceptualized with the programmers and did some part in writing the integration tests together with the programmers. Exactly those tests here were actually developed together with two game designers, but they don't actually write code. And for the projects that now use this framework, it is not necessary anymore at that level because that's covered in the framework.
Okay, and how long did it take from you to make this system? It appeared not in this project as far as I understand.
It didn't appear in Jagged. It is in Shadowrun Online. It is already being used. And we started in November, I think, or so. November 2012. And it was basically finished in March or so. It lived, actually, the most time that was spent was with iterations until both designers were happy with because you have to make some restrictions. In order to generalize that, something like that, you have to enforce some restrictions, otherwise you can't generalize. And so it took a little bit of iteration till they were happy till they completely understood the restrictions. And being a designer, they are not necessarily like us programmers. They don't understand a set of inputs and then predict the future. So if you tell them the restrictions, they still don't quite understand it. So there were certain things that they only later, that means this. And so we had some iterations with the framework. And the other thing was like making it more comfortable. There were a lot of details that the game programmers in the game teams added as kind of customers to this system and said, hey, it would be more comfortable to have it like that. So a huge part of the system, of the time taken to implement the system was actually this refinement. Initially finished, it was, I think, by end of December or even before Christmas. It went really very quickly from the implementation point of view, but then these iterations took a while.
Okay, great, thank you.
Если больше вопросов нет, есть еще вопрос?
Hello. So I wanted to ask how you integrated this beautiful model, data-driven, with graphical equipment. I mean, so for example, as I understood, the graphical subsystem, all your views, they working with these compositions. Yes.
Yes.
So. Is it optimal to pick the data and to understand what this data means and to draw it properly? I mean, haven't you faced any speed issues? I mean, any performance issues?
Okay. No, actually not at all. And really, we don't do so much. We just load the data. Most of the data is being loaded only once at startup, because it's basically like templates, and then you have an instance of that. And if you, for example, activity itself doesn't have any state that changes at runtime. It does have all those properties. You load them once, and that's it. So activities can be reused. The object, the instances, and that is the case for many, not necessarily all. Okay, not necessarily all. Entities in the game, and so most of the stuff we can just load it at startup, and it takes nothing. So it's not even noticeable to load the entities so far. I mean, maybe we will find out if the designers add too many items, then we will have to do some profiling. But so far, this hasn't happened.
Thank you.